In this section, we're going to look at the inverse of a matrix. We've explored addition, scalar multiplication, subtraction, and matrix multiplication for matrices. We've seen that a matrix always has an additive inverse. We might wonder if a matrix has a multiplicative inverse. The inverse of a matrix A is any matrix B such that when you multiply A on the left and on the right by the matrix B, you get the identity matrix. So it looks like this. Okay, so if A is given and we want to know if A has an inverse, let's say there's another matrix B such that when you multiply on the left and the right, like this, you get the identity. And the inverse of A, the inverse is denoted like this. A little minus sign here. In matrix algebra, there is no division, but the analog of division is the inverse matrix. Let's do an example. So let's say A is given as this matrix. Then we can find the inverse of A. Actually, there's a formula for that for 2 by 2 matrices. So let's say A was like this. Then the inverse is given by this formula. One over AD minus BC times the matrix that you get here if you swap the A and D, and then attach a minus sign to B and C. Okay, so this is the formula for the inverse of A. This only applies for 2 by 2 matrices though. Okay, let's apply that here to this matrix. So take 1 over AD minus BC times the matrix that you get by swapping the 2 and the 4 and attaching a minus sign here and here. Okay, so let's simplify this. Distribute that 1 over 8. So we get this. Okay, so this is the inverse of A. Let's see if this actually gives you the identity matrix when you multiply with A. Okay, so A times A inverse is going to be this. And multiply this out, you get 1, get 0 here, negative 1/4 plus a fourth, which is 0, and 1. Okay, so we do get the identity matrix on the right hand side here. Let's multiply A by the inverse on the left, and we should also get the identity matrix. Okay, so that's 1, 0, 1 half minus half, which is 0, and 1 here.